Hi, it's Jan Beta, and in the last video I inspected this Commodore 128. That's actually just the top cover, because I haven't reassembled it yet, because I haven't even tested it yet, because I didn't have a power supply, and this is hopefully going to change today, because my plan today is to build my own power supply. This is all things I'm going to use, except for maybe some improvised stuff that I'm gonna make up as I go. About the same case that I used for my Commodore 64 power supply that I built a while back. I'll link in here. I'm using a Meanwell 5 volts power supply, switching power supply, which is supposed to be pretty okay. Didn't test this particular one, this particular model, but most people say these are working nicely for the job. Rated at 3 amperes, the original Commodore 128 power supply is rated at 2.5 ampere. This is a 9 volt transformer, 230 volts to 9 volts AC transformer. This is a 4-strand cable, which is usually used for lamps and stuff like switching 2 bulbs on in one lamp and stuff like that. These are fuse holders, so I'm going to fuse this. This is just a regular mains cable. It's a bit flimsy. I hope I can find a better one. But this is what I have here now. So for assembling this, and this is a power switch. I don't know if I can fit this in there, but I think I'm gonna try, because it would make sense to have a power switch. And as I already mentioned in the last video, the Commodore 128 uses the same 5-pin DIN, square DIN connector that the Amiga models used. The 5-pin square DIN plugs are no longer in production, as many of you retro enthusiasts might know. Actually, some new old stock ones reappeared mysteriously a while back, and as it so happens, the person who found the new old stock donated quite a few of these 5-pin, beautiful black 5-pin square DINs to me, and he also sells them on his website. And as it so happens, he also has a very good retro YouTube channel that I'm gonna link in here, and it is Jeff Bird, who he's one of those people who actually know their stuff and make YouTube videos about it. I've learned a lot about Commodore 64 power supplies from him, actually, so definitely check out his channel. He deserves far more attention than he currently got, so highly recommended to check him out. He also sells these from his website. I think he got some new stock in at the moment, so you can just order these. And that's pretty nice. It's pretty good news for the retro community, I guess, because these were unavailable for quite a while, and I was looking all over the world for these. Jeff found them, and he sells them to the community. So I'm gonna link that in below in the video description. And also check out Jeff's channel, please. Okay, so first things first, let's see if we can fit the components in the case, which is a Bopla E440VL, it seems. I'm gonna put a link in the description so you can buy the exact same case if you so desire. You could also use a different case, of course. This is just a suggestion of what I am going to use, because I already know the case and it's pretty good. Not that cheap, but works well for my Commodore 64 supply. So let's see if we can fit this in here. I think I'm going to go with the upside down thing again. Yeah, so far so good. It seems to fit in there. Let's see if the fuse holders protrude. We probably can fit them in there. These are pretty hefty I think they are rated for 6 amps or 10 amps. Pretty good stuff. Yeah, I think it's gonna fit fine. I also got this and printed it out from Drunken Retro, who have a tutorial on how to build an adapter from Commodore 128 power supply to Commodore 64 power supply, I think. Which is something I want to do in the future, I guess. For now, I just need a Commodore 128 power supply. And the pinout on this was the most conclusive I could find on the web, because it has the female side, which is the jack side, and the plug side, which is the male side with the protruding pins. You know why this is called male. There is a conclusive pinout, and as you can see, the Commodore 64 has 9 volt AC and 5 volts DC, and the Commodore 128 has 9 volts AC and 5 volts DC. So they are pretty much compatible with each other. The only thing is that the Commodore 64 power supplies don't supply enough amps on the 5 volt rail. The 9 volts only need 1 amp. The 5 volts needs 2.5 amps, so I'm going with the 3 amp Meanwell switching power supply. So that's what we're going to do. I'm going to wire up the connector to the cable and wire up the internals of the power supply. So here's what we're going to do. This is our mains, 230 volts in my case. You should, if you have another mains voltage, you should of course use another transformer and another PSU, obviously, that is suitable for your mains voltage. This is the German mains voltage. Most of Europe has similar mains voltages, so you can probably go with this if you are in Europe. So we have our mains that goes through a primary fuse. Maybe we are going to put a switch here. I'm not sure about that yet. Would make sense. Maybe we'll put a switch behind the fuse. Don't know what's the better way of doing it. So then we have our transformer. That is a 230 volts to 9 volts transformer that goes straight to the output with 9 volts AC output voltage. And then we have our 5 volts PSU connected up in parallel, and we are going to fuse the positive side of that with a secondary fuse. So if something shorts out on this end or something goes horribly wrong with the computer, the fuse blows, which hopefully won't happen. So that's the plan. Let's see if we can make it. First of all, we should prepare the case to take some plugs here, stuff like that, so we can insert our stuff. You know, this power switch is hilariously huge, but I think we could Dremel out something there and use this. This is rated for 16 amperes, so that's plenty for our purposes. Yeah. So I am going to. There has to be a switch on the primary side. There has to be our mains cable, and there has to be the primary fuse on the primary side. So I'm going to attach that. I think I'm going to mock it up. So here's the little mock-up. I'm gonna cut this out. There's gonna be the mains cable, there's gonna be the fuse or thereabouts. We need on the other side, we need a hole for the output cable. Should be dead center. And we're going to put in our secondary fuse like here. So okay, these are the pilot holes. Looks pretty nice. Now for the power switch here. Oh, I drilled out the holes for the cables a bit more. Maybe that's a bit much, but we're gonna see about that. And here's what I also got. It was one of my Christmas presents actually, but I haven't really used it. At least not in the video. I used it for some household stuff. It's one of those Proxon Dremel equivalents, which are supposedly even better than the real Dremels. I heard, I don't know. Don't know for sure. I'm going to use this to try to cut out my little cutout for the power switch. Ha! And it broke. Okay, there we go. Okay, let's see if our switch fits. I think I got all the holes I need, so we're going to go back to the bench there. Okay, back here, and of course we have some filing to do to fit this in, but it's gonna be alright. I think I want the on position down because it makes more sense, like so. So I'm filing this until the switch fits this hole, I guess. I'm not gonna film this, it's probably annoying enough for me already, so I don't want to bore you with it. I'm just gonna do my magic trick. There we are. That was kind of easy. Just filed down the edges a bit more. So now this is sitting nice and tightly. So now for the other components to fit in this. Let's see. Something like this probably. Let's see if it still closes up nicely. Okay, it still closes up nicely. Switch works. So off camera I inserted these little grommets, which are basically, show you, little rubber rings that hold the cable so it doesn't go on any sharp edges in the case, and also it's easier to use as a bit of strain relief so it doesn't slide out of the case accidentally. The hardest part is to insert the cable through the grommet, the rubber grommets, because it's a pretty tight fit. So we're gonna make this, cut this mains cable and put it into the other thing there. This is okay. So we can't use this, it's just garbage, sadly. So this goes in here. By the way, I'm not an electronics engineer. Anything I do here is mere guesswork and self-taught knowledge about power supplies and stuff like that. So do any of, if you are doing any of this at home, I'm not responsible for anything you do, or maybe if you blow up your machines, it's all your own responsibility. I'm just showing you how I do this. I don't even know if it works yet, obviously. So, yeah, keep that in mind. Don't try this at home. So, time to strip the wires. Okay, this looks nice. 9-volt AC is brown and white in the original, so I'm going to use brown and gray for the 9-volt AC. That are, by the way, going to come out of the side of the transformer with the pins closer to each other, which is usually the secondary side. It's with this transformer, it is the primary is the one where the pins are further away from each other. So I don't think it's as clearly marked on here, so that's probably, yeah, it's probably a reasonable thing to go by. No guarantee this works for all transformers, but I think it's kind of, sort of a standard. At least it works for these, which are HAHN, which is a German brand. I think they are quite good. I don't really know much about them, but they have all the little logos, and they came from a respectable, reputable seller, so it's going to be alright. So I need quite some wires, I think, to go from and to and through the transformer and the fuses, and yeah, so first thing, there's that. I'm going through the fuse at first because the reason going through the fuse first in any kind of electronics is, if anything else, even the switch can have, under weird circumstances, the switch could produce a short, so the fuse would immediately blow if it's in front of the switch. So that's a good thing, I guess. Let's tin these wires here. So the mains goes in here. Our hot mains connection. So from there, our connection goes to the switch, and from the switch it should go through to the transformer. So I am going to put this, tin this here. First off, I'm going to insert it here. So, okay. So there's our hot mains, and this goes through the switch to the other side. The switch really is oversized by a lot. It's pretty much overkill for this flimsy couple of watts circuit. It's probably better to go too big than too small. Like with most things in life. Yeah, no, forget that. Burn! No, don't burn. Shrink! Like the other evil magician said. So there we are. That's our nicely shrunk. Now we have this thing which switches the mains to this tab here, which should then be connected to the transformer. And for that purpose, we are going to see how we are going to fit this in here. So, alright, our transformer can go here, and the other thing, the power supply can go here. Obviously, the transformer is for mounting on a PCB. You can, of course, buy a better one that has some solder tabs or something like that. I didn't find any quickly enough for this video, but yeah, there probably are plenty of better ones for this purpose. Ha! That was hot. Yeah, solder is hot. Man, I'm doing quite a horrible job here at the moment. So, both of these are going to go together. A huge blob of solder. And this little thingy is going to be their new home. Like so. So, and the same goes for the blue wire. Need some additional blue wire to wire up the the little supply there. Yeah, I'll be right back. I'm getting some blue wire to wire up the neutral. Okay, found some blue wire. Gonna strip this. This came from another mains cable. So it's horrible, of course, to solder to these. So if you have any chance, get a transformer with proper tabs on it to solder to. So, and in order to solder wires to this supply, I'm gonna desolder these sockets here. So you could, of course, buy the matching plugs for these, but I didn't do it because, yeah, this is not meant to be modular or anything. This is just meant to be assembled once and then hopefully last a while. So, yeah, I think I'm just going to desolder these and solder the wires directly to the PCB. To the desoldering station. So this is even marked for AC live, AC neutral. So we're going to wire it just like that. And the other side is, of course, obviously, which makes sense, minus and plus. V minus V plus. Or minus V plus V is what it says. So that's our 5 volts. So there's our neutral, N neutral. Okay. Nice and shiny. It looks a lot shinier than the old solder because it is solder that contains lead, obviously. The solder I'm using because it's much easier to work with. So if you try to solder and people told you to use lead-free solder, do yourself a favor and try leaded solder at first because it's so much easier to work with. And it's also a bit more flexible, so it lasts longer, usually. That's why some new electronics don't last very long, because solder joints break easily. They are not as robust when it comes to heat differences and stuff like that. So that's our input wired to the little circuit board here, and now we're wiring the outputs. Shall we? So we're nearly done with this. just have to put these through the fuse. So, and here's something that got criticized quite a bit. The colors in this cable are green and yellow, which should never be hot or anything like that, because it is ground or earth even, as per convention. But I only have this cable that has 4 strands in it, so I'm going to use that for the 5 volts. Black is going to be my negative, and the green and yellow is going to be my positive. So I can do this because this is for my own use only. I wouldn't recommend to do this in any more serious environment. I know what I did here, so I'm probably gonna get away with it, but it's not good. It's not good practice at all. So these are going to the AC, the brown and the gray, black and the let's call it red wire. Ideally go to a little circuit board. It's the black one, it's the negative ground, and the ground one is the 5 volts one, which is of course utterly dangerous. Sorry about the hum, by the way, if you can hear it in the background. I had to turn on the fan because it's getting very, very hot in here. It's the afternoon already. I think I started this in the morning. Took quite a while. So, okay. Let's slide some heat shrink tubing over here. So this goes to the same side. Let's do this way. Even though it's AC, it probably doesn't matter, but let's go. Let's put the brown on the brown side. And the grey one, grey side. So now we're going to try to get this out and put our earth wire to the positive. The red wire and the black wire in here. So there we go. That's the internal connections, I think. Oh my god, I forgot to wire the fuse. That's kind of stupid. Okay, of course I wanted to wire the fuse for the hot here. So then we can have our red wire. Let's see. We can desolder this. Solder in the red wire I prepared earlier. So this is really red wire. The real life red wire for the positive. Okay, now we have a red wire for our positive, which is brilliant. Okay, so now I'm going to put some heat shrink over there, like before. This time for real. And this goes to the fuse. Now this goes from the output of the little switch and power supply to the fuse, and from the fuse into our rest of the cable. So this should be our internal wiring now. Doesn't look too bad. Now I have to come up with something to hold the little circuit board in place and the transformer. I mean, there's nowhere they can go really, but should fix them to the case and also secure the cables in there. And then give it a little test run with the multimeter, I guess. Woohoo, exciting. So I decided on testing this before I fix everything, in case I have to change stuff. So I am putting the sleeve of the plug over the cable now, because I tend to forget and never do it now. Chances are I'm gonna leave it on there in the excitement of assembling this in the end. So, alright, so now we should get out the multimeter and test this thing. What I'm also going to do is to write down my pinout here. Black, brown, this is gray. I'm probably going to write it black, brown, gray. Green, yellow is my plus 5 volts DC. So okay, this is now hot. I turn it on and I should be able to measure 230 volts AC on the input side and 11 volts on the output side. There's 11.5 volts, which is the transformer without a load, which is pretty normal that it's 11 volts or thereabouts. Yep, and there's 5 volts. That's our 5 volts, alright. Yep, 5.1 thereabouts. A bit shaky. 5.1. Yep. Everything alright. So I guess we're ready to solder on the plug, which is another DIN plug, but it's a square one, so it's a bit easier than the round DIN plugs. Okay, let's get it on. By the way, I'm going with the female view from here, because that's the solder side. So pin 1 plus 5 volt, pin 2, which is the bottom left here, should be the black one. So pin 3, which is the top right, should be the brown wire, 9 volt AC. Part 1. So, and our gray should be pin 5, which is the center pin. Okay, it's all hunky-dory. Ha! The square ones aren't as bad as the round ones. Nice. So, double checking the pin out. Pin 1, which is the bottom right pin in the male picture, should be 5 volts plus. This should be 5 volts negative. Yeah, and yep, seems to be alright. So let's assemble the plug. So this supposedly goes in here, because there's a little notch. Yep. And this part goes on here, like so. This as well. Okay, nice and tight. Okay, now it should go over there, I guess. Hope so. Are we supposed to slide it? No, we're supposed to slide it from here, I guess. Alright. That clicked into place. And there's our 5-pin DIN plug. Ah, nice. I actually never thought I would assemble one of these myself. Ever. So, yeah, there we go. So now I'm using some epoxy. Got this Model 2 component epoxy for plastic model building. I'm using some cable ties. Of course, I'm using my fluorescent pink, as they are called, cable ties that I found a while back. These are pretty nice. Ever since I found those, I'm never going to use any other color again. just kidding. I really like the fact that these exist at all, and yeah, I just had to buy them. So we're going to tie these around the cables so they don't slide out of the case. We're going to put some electrical tape around the loose ends there, going to epoxy everything in place. I'm going to try to make little standoffs for the circuit board from these things, which are from IKEA, for putting screws in the wall. I don't really know what these are called in English. Yeah, I'm probably gonna make a little subtitle there. Dübel in German. So I'm gonna cut these and make these into little standoffs. By the way, touching the little circuit board there is potentially dangerous because there's a 400 volts capacitor on there, which stores real life 400 volts. So if you get crossed there, it's gonna hurt. Yeah, that's professional electronics, ladies and gentlemen. So I'm gonna epoxy these in place there, and then stand this thing top there and maybe secure it with a little screw. Yeah, that's what I'm gonna do. So we need some epoxy. To be mixed. And then I've got 5 minutes to apply them. So there's my little standoffs, and I have to be a bit careful with this stuff because it dries pretty quickly. It's a 5 minutes epoxy resin, so yeah, basically I have 5 minutes to work with this. Should have put this into place before. Now I should wait 5 minutes, I guess, and come back and see how this went. Be right back. So I put some hot glue on the screws there and some hot glue on the cables there to secure them, some hot glue on the transformer there. Now I'm out of hot glue, so I have to revisit this sometime. But I can't really wait to try this out, and everything seems to hold in place pretty nicely. So I think we're going to test this on the machine, shall we? First off, we have to clean up the lab a bit to have some room for the machine. So let's do that. So I completely forgot to put electrical tape over the connections on the transformer there, which are mains voltage, so you should cover them up. What I want to do. Covering up the neutral is also a good idea, because the European plugs don't have a polarity, so the neutral can be live too, depending on which direction you put the plug in. As we are covering up everything I messed up. So, alright. This seems to hold pretty well. There's my little standoffs there. I'm gonna put more hot glue in there once I bought more hot glue sticks. So I'm going to put the cable ties around the cables there. Which I should have done before I put everything together, I guess. Because now it's pretty hard to reach. tightly tied down so the cables won't slip. On goes the case. So I'm also going to put on some self-adhesive rubber feet as soon as I can find them. I think I found them. Here they are. 12.7 times 3.5 millimeters. So these fit Competition Pros perfectly and a lot of other. It seems to be quite standard size for all kinds of electronics. So I'm just going to put them here. So that's my DIY Commodore 128 PSU. Let's see if it works with Commodore 128. So I don't know about you, but I am crossing my fingers for maybe we have a working Commodore 128. Maybe we don't. Okay, fingers crossed. Turning on the main switch on my DIY power supply. No fuse is blown. Okay, turning this thing on. And we have a signal. Yes! And it totally seems to work. Okay, so it's halfway back together. The keyboard, at least the keyboard is connected to the main board. Yeah, let's try this out. So if we are lucky, the next videos are going to be trying out stuff on the Commodore 128. And this should, if I press the Commodore key, this should give me the Commodore 64 mode, which it does. No problems whatsoever. Nice. Keyboard works. Don't have anything connected, apparently. So the numeric keypad doesn't work in Commodore 64 mode. Basically only the Commodore 64 keyboard that's on your works in Commodore 64 mode. Yes! So let's press the reset switch that should be on here somewhere. That should go in Commodore 128 mode, which it does. So. Oh, okay, I see. So yeah, as you can see, this thing that we just built, or that I just built, totally works. Yeah. I'm going to do some more testing and see how it holds up if I let it run for some time. So I have tested my power supply for quite a while now and it appears to be working. It gets pretty warm to the touch. The switching power supply gets pretty warm. I settled for now for fuse sizes of 315 milliamps for the primary fuse and 3.15 amps for the secondary, which is on the high side, I think. But it should be fine and they should still blow if anything serious goes wrong, anything shorts out. So the next videos are probably going to be refurbishing this and then trying out some stuff to do with it. I think there's a lot of fun things we could do with it. So anyway, thanks for watching. If you like this, subscribe to my channel. There's plenty more of Commodore videos and other systems. Some audio stuff here and there, but mostly retro computers at the moment. If you want to give me some support, you can check out my Patreon page, which I'm going to link in there, where you can give me some support on a monthly basis, because I basically don't have much money, and this stuff costs a lot of money and takes a lot of time to make these videos. So hopefully you like this. Hope to see you again on this channel pretty soon. I'm Jan Peter. Thanks for watching. See you next time. Bye.